All right, welcome back to another deep dive.
Good to be here.
So today we're looking at something pretty specific,
Mm-hmm.
the PureLink OLC the third.
Hmm.
And we've gone through, the data sheets, the installation guides, all of it.
Everything we could get our hands on.
And really, the mission for today is pretty simple.
Mm.
Why does this thing, which is what, barely 3 inches long, cost over $1,000?
Yeah, it's a very fair question to ask. I mean, you look at the price tag, something like $1,075, and it just jumps out.
It really does.
But this is definitely one of those cases where you have to look at the problem it's built to solve.
And that's distance, right? The classic copper ceiling.
The copper ceiling, exactly. You try to run a standard DVI cable,
50 feet, maybe?
50 feet if you're lucky, and you start to see sparkles or,
Or just nothing, a total signal drop.
total signal drop. It's just physics at that point. So
Yeah.
this little box, its entire job is to get around that by, well, turning electricity into light.
Using that OM3 multimode fiber.
Right, the OM3, which is important. It's not just any fiber optic cable.
It's the stuff that's optimized for lasers, isn't it?
Precisely. And by switching to optical, you're suddenly pushing that signal up to 980 feet.
Which is just, it's almost 300 meters. That's insane.
3 football fields. And this is the part that really got me.
Go on.
It does all of this over a single strand of fiber.
See, that's what I was going to ask about, because usually you need 2, right? One for data, one for,
Yeah.
what, the clock signal or something?
It's exactly, or for EDID, handshaking. But this pushes everything down one single literal thread of glass. And we're not talking about like basic HD video,
No, the spec sheet says it supports WXGA resolution.
which is 1920 by 1200.
That 16:10 aspect ratio you see in, I don't know, corporate presentations or high-end control rooms.
Right, and pushing that many pixels with that extra vertical space down one tiny strand with no latency, that's some serious engineering.
Okay, so that helps explain the cost. You're paying for the engineering. But I can still find cheap fiber extenders online. Why is this one 4 figures?
It really comes down to the brain inside the connector. Those cheaper ones are often just dumb pipes. They just shoot light.
And this one is different.
This one has real-time EDID programming.
Let's unpack that, because anyone who's set up a projector knows ED nightmares.
Oh, yeah. That's when your computer just doesn't see the screen, right?
Stop.
And it either shuts off the port.
Or it defaults to like 640 by 480, and your whole desktop layout is just a mess.
Yes. So what this does is it essentially fakes the handshake. It tells the source, hey, the monitor's right here. Everything's fine. Instantly, no flicker, no input not supported message.
So you're paying for, well, not just for the distance, you're paying for reliability.
Reliability is the product. It's also HDCP compliant, so you won't get a black screen if you're playing protected content.
And in a professional setting, a blank screen during a keynote costs a lot more than this little box.
A lot more.
And speaking of the box itself, it is tiny.
Incredibly small. The dimensions are about 3 inches by 1.5 inches.
So it's designed to be, what, stuffed behind a rack or taped to the back of a monitor?
Pretty much. And since those places are often really hard to get to up on a lighting truss, inside a wall,
You definitely don't want to be climbing a ladder to reset it.
you absolutely do not. Which brings us to maybe the most important spec on the whole sheet, the MTBF,
The mean time between failures.
which is rated at 50,000 hours.
50,000. I
Yeah.
really did the math on that. If you run at 247, that's almost 6 years.
Right. It's the definition of a set-it-and-forget-it's device. You install it and you trust it's going to work for over half a decade without a reboot.
So let's bring it all together.
Okay.
For, your home theater, this is complete overkill.
Oh, absolutely. But if you're setting up a stadium, a convention center, a university lecture hall,
Copper isn't even in the conversation at that point.
not at all. So the big takeaway is, for professional work over any real distance, you have to use light. Fiber always wins.
And with this specific unit, it's the onboard processing that wins on stability. It just highlights how much we take this kind of infrastructure for granted. We all stare at these massive, beautiful LED walls at a concert or a conference.
Yeah.
But the real hero is this invisible 3-inch box working away in the dark somewhere, just turning electrons into photons so the show can go on.
That's such a great point. It makes you think, as our screens get bigger and our content gets sharper, the most critical part of the system isn't the giant screen. It's the tiny, almost invisible thread of glass connecting everything together.
Definitely something to chew on. Thanks for breaking this down with us.
Always a pleasure.